Imagine, if you will, a new frontier opening before us. It is vast, largely untouched, and brimming with unimaginable riches. This frontier isn't a newly discovered continent on our familiar Earth, no. It is something far grander, far more immense, stretching into the void. It is the dark, silent expanse of space that surrounds our precious world. More specifically, we are talking about the asteroid belt, and even beyond. Countless rocks, ancient remnants of a solar system in its fiery making. A cosmic treasure hunt is about to begin, and you, yes you, are invited. Are you ready to explore this breathtaking new possibility with us today? Let us embark on this incredible journey of discovery, into the unknown. Billions upon billions of rocky metallic bodies drift through the cosmos. They are silently orbiting our magnificent sun, our star. These are the asteroids, the minor planets, the solar system's leftover building blocks. They are silent witnesses to the birth of planets, including our own Earth. For eons they have tumbled through the darkness, holding their secrets close. What mysteries do they conceal within their ancient cratered surfaces? What incredible treasures lie waiting to be discovered by intrepid explorers? The universe whispers its secrets to those who dare to listen, to those who dare to look up. And these space rocks have so many stories, so many riches to share with us. Their silent chorus calls to our innate curiosity, our desire to understand. We, humanity, find ourselves standing on the very precipice of a new era. It is a moment pregnant with possibility, a moment of profound choice. Can we, the inquisitive apes who learn to walk upright and dream of stars, reach out? Can we develop the ingenuity and the courage to tap into this cosmic abundance? The resources locked within these celestial bodies could reshape our future. This essay is your personal invitation to explore this very idea, to delve into the science, the promise, and the challenges that lie ahead. Consider this your boarding pass to a voyage of the mind, a journey of potential. We will navigate the concepts, the hopes, and the unfolding realities together. The cosmos beckons, offering solutions we've only dreamed of until now. So, join me, won't you? Let us journey together into this fascinating realm. Let's explore the world of asteroid mining, a concept leaping from fiction to fact. This is a future where our species' reach extends far beyond the blue skies of Earth. We are venturing into the grand, dark, beautiful ocean of interplanetary space. It is a place of wonder, a place of challenges, and a place of immense opportunity. The story of asteroid mining is not just about rocks and metals, you see. It is about the next chapter in the human adventure, our cosmic destiny. It is about securing a sustainable and prosperous future for generations to come. Fasten your seatbelts, open your mind, and prepare for an extraordinary exploration. The universe has laid out a path of discovery, let us walk it with open eyes. Earth, our beautiful, irreplaceable blue marble suspended in the vastness of space. It has given us everything we know, everything we are, everything we cherish. Life itself, in all its breathtaking diversity, blossomed here, and only here so far. It has provided the resources, the air, the water, the shelter for our civilization. It is our cradle, our home, the only one we have ever truly known. But our planet, for all its generosity, is finite, its systems delicate. Its treasures, though once seeming endless, are now showing their profound limits. We must acknowledge this truth if we are to navigate the future wisely. The Earth has nurtured us, and now it needs our understanding and our care. Its silent plea for balance is growing louder with each passing year. We are a species that has grown, and grown rapidly, in numbers and in impact. Over 8 billion souls now share this planetary home, and the count continues to rise. Our collective appetites for energy, for materials, for land are truly immense. To satisfy these needs, we dig deeper into the Earth's crust, we consume more. We transform landscapes, alter ecosystems, and stretch resources to their breaking point. The Earth, our patient provider, groans under the ever-increasing strain of our demands. This is not a judgment, but an observation of our current planetary condition. Our ingenuity has brought us far, but it has also brought new, complex challenges. The scale of human activity now rivals the great forces of nature itself. We must find a new way, a more sustainable path forward for all. Look around you, observe the signs, listen to the scientific consensus. Climate change, driven by our reliance on fossil fuels, alters weather patterns. Pollution of our air and water taints the very elements that sustain us. Depleted mines and dwindling reserves of critical materials signal a coming crunch. These are not merely distant headlines or abstract scientific warnings anymore. They are the clear, undeniable symptoms of a planet struggling to keep pace. Our world is working hard to accommodate our ever-expanding global demands. We need new thinking, innovative solutions, and perhaps a new perspective. The problems are complex, interwoven, and require bold, systemic changes. Our creativity, the same that built our current world, must now help heal it. Perhaps, just perhaps, the answers we seek lie not only here on Earth's surface, but also beyond it, in the vast, unexplored territories of our solar system. The pressing challenges here on our homeworld act as a powerful catalyst. They compel us, they push us, to lift our gaze upwards towards the heavens, to the silent, glittering promise held within the countless stars and asteroids. This is not about escaping Earth's problems, but about finding new ways to solve them. It is about alleviating the burdens we place upon our terrestrial environment. The cosmos, in its infinite wisdom, might offer a lifeline, a new source of hope. The call from afar is a call to innovate, to explore, and to evolve. Let us consider how the void of space might hold keys to Earth's continued vitality. So, what exactly is this grand, ambitious idea we call asteroid mining? It might sound like something straight out of a science fiction movie, doesn't it? A fantastical notion of spaceships drilling into giant rocks floating in the void. But the core concept, when you strip away the Hollywood gloss, is remarkably simple. It means developing the capability to travel to these asteroids, these small worlds. These celestial bodies are drifting relatively nearby in our cosmic neighborhood. We aim to identify those that are rich in specific, valuable materials we need. It is essentially prospecting and resource extraction, but on an extraterrestrial scale. A new kind of gold rush perhaps, but with implications far beyond mere wealth. It's about securing the building blocks for our future wherever that may lead. How would we go about this extraordinary feat of cosmic engineering? Initially, we would send sophisticated robotic spacecraft, our tireless emissaries. These probes would be equipped with advanced sensors and analytical tools, or perhaps, one day in the not-too-distant future, even human crews will venture forth. These missions would meticulously survey and map asteroids, assessing their composition. Think of them as robotic geologists, or cosmic prospectors, scouting the solar system. They would be searching for celestial gold, platinum, water, or other vital elements. Their data would guide us to the most promising candidates for resource extraction. This careful reconnaissance is the crucial first step in harvesting the heavens. Precision and patience will be paramount in this new form of exploration. Once a suitable asteroid, rich in the desired resources, is identified and reached, the next phase, the actual mining operation, would commence its intricate work. This could involve various techniques depending on the asteroid's type and structure. Perhaps robotic arms would scoop up loose surface material, the regolith, or specialized drills might bore into the asteroid to access deeper deposits. Some concepts even envision enclosing an entire small asteroid in a containment system. The extracted minerals, water ice, or other useful elements would then be processed. These resources could then be utilized directly in space for construction or fuel, or, for certain high-value materials, they might be carefully transported back to Earth. It's the birth of a new interplanetary supply chain, a cosmic logistics network. But why go to all this trouble? Why invest so much in reaching for these space rocks? This endeavor isn't just about acquiring more stuff or getting unimaginably rich. At its heart, asteroid mining is about striving for a more sustainable future. It's about lessening the immense environmental burden currently placed on our home planet. Imagine reducing the need for destructive terrestrial mining practices, healing Earth's scars. Furthermore, these extraterrestrial resources could provide the essential building blocks, the materials needed for human expansion and long-term presence throughout the solar system. This could herald a new chapter for our civilization, one of cosmic self-sufficiency. It is a bold vision, one that transforms us from earthbound to spacefaring. The implications are truly staggering, touching every aspect of our future. What incredible treasures, what cosmic jewels, truly await us in these distant space rocks. Forget the romanticized pirate chests overflowing with gold doubloons and rubies. Think bigger, think on a cosmic scale, think of the raw materials of creation. Asteroids are, in essence, fascinating time capsules from the dawn of our solar system. They were formed from the very same primordial cloud of gas and dust as our planets. As such, they hold vital clues to our planetary origins, to how Earth itself came to be. Studying them is like reading a previously untranslated chapter in our cosmic history book. Their composition reflects the diverse ingredients available in the early solar system. Each one is a unique testament to the chaotic, beautiful process of planetary formation. Their secrets are not just material but also scientific, offering profound insights. Many asteroids, particularly those known as M-type asteroids, are incredibly rich in metals. We're talking about vast quantities of iron, nickel, and cobalt, familiar elements. These are the fundamental workhorses of modern industry, the backbone of our infrastructure. They are absolutely essential for building everything that defines our technological society, from the towering skyscrapers that pierce the clouds to the smartphones in our pockets. From the cars we drive to the bridges that span our rivers, these metals are key. Now imagine an almost limitless supply of these vital materials readily available, floating just a relatively short cosmic journey away in the asteroid belt. This abundance could fundamentally change our approach to manufacturing and construction. The scale of these metallic reserves in space dwarfs what remains easily accessible on Earth. Then, there are the truly exotic and exceptionally valuable prizes hidden within asteroids. These are the platinum group metals, often referred to as PGMs. This exclusive club includes platinum itself, of course, but also palladium and rhodium. And let's not forget iridium, osmium, and ruthenium, each with unique properties. These metals are extraordinarily rare on Earth, found in only a few select locations. Their scarcity makes them incredibly precious and economically significant. Yet, certain types of asteroids are believed to be absolutely packed with them. They are essential in catalytic converters for cars, purifying emissions. They are used in advanced electronics, medical devices, and even cancer treatments. Sourcing these from asteroids could make them more accessible for beneficial technologies. And the bounty doesn't stop with just metals, whether common or precious. The diversity of asteroid compositions means they offer a wide range of resources. Some asteroids are rich in silicates, which can be processed into materials for construction. Think of building habitats or radiation shielding in space using locally sourced rock. Others hold significant quantities of phosphorus, an element absolutely vital for agriculture. On Earth, phosphate rock is a finite resource, crucial for fertilizers that feed billions. And perhaps most critically, many asteroids contain water, the very elixir of life. This water is often locked away as ice, especially in C-type or carbonaceous asteroids. It's a veritable cosmic supermarket, with aisles stocked for a space-based civilization. The potential to find and utilize these varied resources is truly transformative. Section 5. Beyond gold, the strategic metals up above. Let's delve a little deeper into those remarkable platinum group metals, the PGMs. On our home planet Earth, discovering and extracting these metals is a difficult business. They are exceptionally scarce, found in economically viable concentrations in very few places. Often they are byproducts of mining for other metals like nickel or copper. This profound scarcity naturally makes them incredibly valuable in our markets. And as a consequence, their supply chains can become politically sensitive, even contentious. Nations that possess significant reserves hold considerable economic and strategic leverage. The quest for these materials has, at times, shaped global trade and politics. Their importance in modern technology means demand is consistently high and growing. Asteroids offer a potential way to diversify and secure these critical supplies. Now, try to visualize this: a single, moderately sized metallic asteroid. Let's say it's an M-type asteroid, specifically chosen for its high metal content. Imagine it's perhaps just 1 kilometer in diameter, a mere speck on the cosmic scale. Yet, an asteroid of this nature could potentially contain more platinum group metals. More platinum, palladium, iridium, and their kin than have ever been mined in the entire recorded span of human history on planet Earth. Pause for a moment and let that staggering thought sink in fully. The sheer, almost incomprehensible scale of these extraterrestrial resources is mind-boggling. It redefines our understanding of scarcity and abundance for these critical elements. This isn't just a small increase, it's a paradigm shift in resource availability. These remarkable metals are not merely destined for creating beautiful jewelry or luxury items. Their true value lies in their unique chemical and physical properties, vital for industry. They are indispensable catalysts in a vast array of green technologies, for instance. Fuel cells, which promise clean energy for transportation and power generation, rely on platinum. They enable more efficient chemical processes, which can significantly reduce industrial pollution. By sourcing these crucial metals from the abundant supplies in space, we could potentially accelerate our global transition towards a cleaner, greener Earth. Imagine a world where the materials needed for sustainability are no longer a bottleneck. The environmental benefits of asteroid-sourced PGMs could be immense for our planet. This is a powerful argument for looking towards the heavens for terrestrial solutions. And let's also consider other strategically important elements beyond the PGMs. I'm thinking here of the rare earth elements, or REEs, a group of 17 metals. Names like neodymium, dysprosium, and yttrium might not be household words, but they are absolutely crucial for much of our modern high-technology infrastructure. They are essential components in the powerful permanent magnets used in wind turbines. They are found in our smartphones, our laptops, and our electric vehicle motors. Medical imaging devices like MRI scanners also depend heavily on these elements. Currently, the global supply of REEs is dominated by a very small number of countries. Asteroids could offer a new, more diverse, and potentially more abundant source. This could free critical technologies from geopolitical constraints and supply vulnerabilities. Section 6. Water worlds and miniature asteroids as cosmic wells. Perhaps the single most valuable resource we might find in the cold expanse of space isn't a gleaming, lustrous metal, nor a rare and exotic element for our gadgets. It's something far more fundamental, something intrinsically linked to life itself. I am, of course, speaking of water. Simple, humble H2O, the very medium in which life as we know it arose on our planet. And it turns out that many asteroids, particularly the dark sea-type or carbonaceous asteroids, are surprisingly rich in water, typically locked away in the form of water ice or chemically bound within hydrated minerals, like clays, within their structure. These water worlds in miniature could be the oases of our future solar system. Their aqueous bounty holds the key to unlocking humanity's potential beyond Earth. Why is water considered such a profoundly important resource out there in space? Well, for starters, human beings, astronauts exploring the final frontier, can drink it. This is obviously essential for sustaining any long-duration human presence away from Earth, but the utility of asteroidal water extends far, far beyond mere hydration. Using the power of electrolysis, we can easily split water molecules, H2O, into their constituent components, hydrogen and oxygen. Hydrogen, when cooled to cryogenic temperatures, becomes a potent and efficient rocket fuel. And oxygen, well, that's rather useful for something we all do, breathing. So, asteroid water provides not just sustenance, but also propellant and breathable air. It is the ultimate multi-purpose resource for any aspiring spacefaring civilization. Imagine, for a moment, a network of cosmic watering holes or refueling stations. Strategically located asteroids, rich in easily accessible water ice, scattered throughout the inner and outer solar system, like stepping stones across a vast river. Spacecraft, embarking on long voyages to Mars, Jupiter, or even further afield, could make pit stops at these asteroidal oases, replenishing their vital supplies. They could take on fresh water for the crew and generate their own rocket fuel. This capability would dramatically, fundamentally, lower the cost of space exploration and travel. It would reduce our reliance on launching everything, including massive fuel tanks, from Earth. The tyranny of the rocket equation, which dictates how much fuel is needed, would be lessened. Asteroids could become the gas stations and rest stops of the interplanetary highways. This concept is known as in situ resource utilization, or ISRU. It's a fancy term for a very practical idea, using the resources you find where you find them. ISRU is widely considered by space agencies and futurists to be absolutely key. It is the enabling technology for establishing a sustainable and affordable human presence beyond Earth. Consider this: the heaviest component of almost any deep space mission launched from Earth is its fuel. If we can produce that fuel in space, from asteroid water, the game changes completely. Missions become lighter at launch, meaning smaller, cheaper rockets can be used. Or the same rocket can carry much more scientific payload or crew habitat. Asteroid water, therefore, has the potential to unlock the entire solar system for humanity. It is the key that turns the lock on the door to our interplanetary future. Section 7. Trailblazers and Star Dreams, Humanity's First Steps. This grand vision of mining the heavens is not merely wishful thinking or idle speculation. It is not confined to the colorful pages of science fiction novels or blockbuster films. The journey, the incredible human endeavor to reach for and utilize asteroid resources, has already begun. Space agencies around the globe, alongside innovative private companies, are taking this seriously. They are investing significant resources, intellect, and passion into this emerging field. They are busy sending sophisticated robotic probes to study these celestial wanderers up close. They are meticulously developing the complex technologies required for these ambitious missions. The dream of asteroid mining is slowly, steadily, but surely transforming into a tangible reality. We are witnessing the dawn of a new era in resource acquisition and space exploration. The first tentative steps are being taken on a path that could redefine our future. Do you recall Japan's remarkable Hayabusa and Hayabusa 2 missions? These were truly pioneering efforts. JAXA, the Japanese space agency, sent these intrepid spacecraft on incredible journeys. They rendezvoused with distant small asteroids named Itokawa and Ryugu, respectively. They didn't just fly by, they orbited, mapped, and even dared to touch down. And most impressively, they successfully collected tiny, precious samples of asteroid dust. These microscopic specks were then carefully returned to Earth for intensive study. Analyzing these grains teaches us an immense amount about asteroid composition and geology. It also provides invaluable experience in how to navigate near and interact with these small, irregular bodies. These missions were triumphs of engineering and testaments to human ingenuity. They proved that reaching out and touching an asteroid is indeed possible. Then there is NASA, the renowned American space agency, with its own impressive contributions. Their OSIRIS-REx mission, a marvel of precision engineering, journeyed to the asteroid Bennu. Bennu is a carbonaceous asteroid potentially rich in organic compounds and water-bearing minerals. OSIRIS-REx successfully performed a daring touch-and-go maneuver, collecting a substantial sample. That precious cargo of alien rock and dust returned to Earth in 2023 for analysis. And right now, as we consider these things in mid-2025, another NASA mission is soaring through space. The Psyche spacecraft is on an unprecedented voyage to a truly unique celestial object. It is journeying to a main-belt asteroid known as 16 Psyche. This asteroid is thought to be the exposed metallic core of an ancient protoplanet. Imagine an asteroid made almost entirely of iron, nickel, and other metals, a cosmic treasure trove. And it's not just governmental space agencies that are fueling this exciting new frontier. A growing number of ambitious private companies are also entering the asteroid mining game. Visionary entrepreneurs and engineers are founding companies with names like Astroforge and TransAstra. These commercial ventures are designing innovative spacecraft and mission architectures. They are actively planning their own privately funded missions to prospect and eventually mine asteroids. They are driven by the immense economic potential, of course, but also by a pioneering spirit. It feels like a new kind of space race is beginning to unfold before our very eyes. But this time, the competition is not just for national prestige or flags and footprints. It is a race for resources, for the foundational materials of a space-based economy. And ultimately, it is a race towards securing a more expansive future for humanity. Section 8. A future forged in starlight, the Asteroid Revolution. What does all of this pioneering activity, this reaching for the stars, mean for our future? If asteroid mining transitions from bold concept to widespread practical reality, the implications for human civilization will be nothing short of profound, truly transformative. It could fundamentally reshape our entire relationship with resources, with materials. And just as importantly, it would alter our relationship with space itself. We are talking about a genuine revolution, on par with the agricultural or industrial revolutions. A shift that could redefine what it means to be human in the 21st century and beyond. The ability to access and utilize the vast wealth of the solar system changes everything. It opens up possibilities that were once confined to the wildest dreams of futurists. Our destiny may indeed be written not just on Earth, but amongst the stars. Imagine, if you can, a future where the concept of resource scarcity on Earth becomes a relic of the past, a historical footnote in the story of human progress. Imagine a world where the often devastating environmental damage caused by terrestrial mining is significantly reduced, allowing ecosystems to heal and biodiversity to flourish once more, where we can meet our material needs without further burdening our home planet's delicate systems. Imagine humanity building vast, ambitious structures directly in space, not on Earth, using materials that are sourced locally, from the abundant resources of nearby asteroids. Think of enormous solar power satellites beaming clean energy down to Earth day and night, or comfortable self-sustaining space habitats, orbiting our planet or journeying further afield. This is the promise held within those distant, silent rocks, a promise of sustainable abundance. This newfound abundance of materials and energy sourced from the cosmos could fuel an unprecedented era of technological innovation and scientific discovery for our species. New industries creating products and services we can barely conceive of today would blossom. A vibrant, self-sustaining space economy could emerge, creating jobs and opportunities. This would be an economy that extends far beyond Earth's atmosphere, truly interplanetary. It could be the critical catalyst that finally enables humanity to become a genuinely multi-planetary species, with permanent outposts and settlements on other worlds. We would no longer be just fleeting visitors to the moon or Mars, planting flags, but true residents, living and working in diverse environments across the solar system. The transition from a single-planet species to a multi-planet one is a monumental step. Of course, we must be realistic. This grand vision is not without its formidable challenges. The immense distances involved in space travel are difficult to comprehend, let alone traverse. The harsh, unforgiving environment of space vacuum radiation, extreme temperatures, poses constant threats. There are significant technical hurdles still to overcome in robotics, propulsion, and resource extraction. And the economic viability of these ventures must be proven. It must make financial sense. These are not trivial problems. They will require immense effort, investment, and ingenuity. But when has humanity ever shied away from bold dreams simply because they were difficult? We are a species defined by our relentless curiosity, by our unyielding urge to explore. We are driven to reach for what currently seems impossible, to push the boundaries of knowledge. The history of science and exploration is a testament to this enduring spirit. Section 9, The Next Giant Leap. What are your thoughts on mining the sky? We find ourselves standing at a truly fascinating and pivotal crossroads in human history. The vast, silent cosmos, once a realm of myth and distant observation, now offers tangible solutions. It presents a potential answer to some of Earth's most pressing and complex problems. A new frontier, almost unimaginably vast, is opening up, brimming with untapped potential. Asteroid mining, an idea long cherished by visionaries and science fiction writers, is no longer just a distant fantasy, a dream for future generations to ponder. It is rapidly emerging as a distinct and achievable possibility within our lifetimes. The technological pieces are falling into place, the scientific understanding is growing. The will to explore and utilize these resources is building across nations and industries. The implications of this shift are something we all need to consider carefully. This endeavor, this reaching for the riches of the asteroids, promises a future of abundance. It offers a potential pathway to significantly protect our precious home planet, Earth. By shifting some of our resource extraction activities off-world, we can lessen our footprint. It lays out a plausible route for humanity to become a true spacefaring civilization, expanding our horizons, ensuring our long-term survival and prosperity among the stars. But like all great and transformative human endeavors, it comes with profound questions. There are critical ethical considerations we must grapple with as a global community. We must think about the potential environmental impacts not just on Earth but in space itself. And the complex issue of ownership. Who has the right to claim and use these celestial resources? These are not questions with easy answers. They demand thoughtful and inclusive deliberation. These are the crucial conversations that we, as a species, need to be having right now. As the collective inhabitants of this small, fragile, and incredibly precious world, the future development and governance of asteroid mining isn't just a matter for scientists. It's not solely the domain of engineers, corporations, or governments to decide. It is up to all of us, every thoughtful citizen of planet Earth, to engage, to dream about the possibilities, to debate the merits and the risks involved, to help shape the policies and principles that will guide this next great adventure. Our collective wisdom, our diverse perspectives are essential to navigate this path responsibly. The choices we make in the coming years will have long-lasting consequences. We must choose wisely, with both ambition and humility, for generations yet to come. So, after journeying with me through these ideas, what are your thoughts? What is your perspective? Is asteroid mining the indispensable key to unlocking humanity's prosperous future? Do you see it as a necessary and vital step for continued human progress and sustainability? Or do you view it as a cosmic gamble fraught with unknown consequences and potential pitfalls? Perhaps your view is a nuanced combination, recognizing both the promise and the perils. The universe in its silent majesty is now listening for our collective answer. Let your voice, your opinions, your hopes, and your concerns be heard in this global dialogue. Engage with this topic, learn more, discuss it with others, and form your own conclusions. The stars quite literally await our collective decision, our next bold move. The future is not something that merely happens to us, it is something we create together.